All right, welcome to today's first ever math MCAS by mistake. So we'll be going through a bunch of math MCAS 8th grade questions. I'll be making mistakes along the way, looking for you to try to catch the mistakes and find the right answers, along with just kind of reviewing what we did this year in 8th grade math and helping you study to be awesome on the 8th grade MCAS this year. So first question, we're going to try to go in order of the school year, roughly. Brings us back to similar and congruent figures. Particularly, these two figures here are similar. So if they are similar, it totally means that they are proportional. So what we used to do when we were finding missing lengths here is set up a proportion. So let's go ahead and set up a proportion here. So I can see that 6 goes to R. So I'll go 6 goes to R like that. And then I'll go 3 goes to 4.5. 3 goes to 4.5, and you just cross multiply and divide, and you get 3r equals, that's 27, and you divide each side by 3, and you get r equals 9. Now there's a math by mistake there. Can anyone pause the video here and see if you can figure out the mistake? All right, if you figured out that I set up my proportion going the wrong way, so if 6 goes to R, then I have to do 4.5 goes to 3. So the correct solution would look more like this. So I would go 6 goes to R, again, keeping everything in the same, same proportional from one big figure to the small figure, and then 4.5 goes to 3. Now when I cross multiply and divide, I get 18 equals 4.5r. Divide each side by 4.5, of course, and that is actually going to be r is equal to 4. And if I put my answer back in, that makes sense here, that would be r is equal to 4 feet there. So again, remember, similar figures are proportional, so you can always set up a proportion. Remember, they are not congruent, though. Congruent figures are exactly the same. Sticking along with that here, no mistake on this one. I just wanted to make sure you remember, like here, it wants to know the angle of U. So it tells us again that they are, again, similar. So if they're similar, the angles are the same because they're the same shape. So if this is 48, then this one must be 48. So your choice here is answer C. All right. All right. Next question, bringing us to parallel and cut by transversal here. So it says, what is the measure of angle 1? I'm sorry, angle 1 is 120 degrees. So it wants to know what angle 2 is. Sorry, I guess I didn't get my voice all the way back yet. So angle 2 is here. So you can see they're kind of opposite each other. So that one definitely must also be 120 degrees. What's my mistake? Yeah, hopefully you notice that one of them is obtuse and the other one is acute. So if you notice here, this one has to be, if this is 120, right? Well, that also means all the obtuse angles are 120. So that's also going to be 120 here and 120 here. So these now are on 180. So that means this angle 2, which is acute, smaller than 90, has to be indeed what? 60. Once we had the angles, once we had similar congruent and did some angles this year, we moved on to transformations. So let's take a look at this example here. This has multiple parts. So the first part here, let's make sure I got my papers right here. Yeah. So the first part here says, let's try this one. It says, this is L. And then it says here it's going to be reflected over the y-axis. So it's going to be reflected over the y-axis. So I bet you it'll probably end up over here. So everything's definitely going to be in the negative answers. It's negative, negative, because you're going to reflect it here. So the answer would probably be C. Everything will be negative. So obviously that's a math by mistake. Where will L end up, and what will the coordinates be if it's reflected over the y-axis? Well, let's take a look. So it's reflected over the y-axis here. That's your line of reflection. It's going to end up, again, I don't have to be specific, but I know it's going to be in quadrant 1, something like, just sketching it out horribly there. L will be here. So the correct answer is they're both going to be positive. But if I look, there's nothing there that says they're both going to be positive. But one thing that is true, because when I do a reflection, they're still going to be congruent, exactly the same. So the perimeter is equal to the perimeter of the new image. So the perimeter hasn't changed. That's kind of a tricky question. So it's not this one. The area doesn't change. It doesn't intersect any of the axes because you jumped over an axis. So the correct answer there is actually D. Staying along with that question. Yeah. So this one says, what if we translate it 5 up and 3 right? Which of the following must be true? Well, let's go back and look at the image here. And if we go, and I think we're moving triangle T 5 up and 3 right. So 5 up and 3 right. So 1, 2, let me see here. 5 up, 3 right. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so something like that ish. All right. Well, I guess everything over here, it's back in quadrant 1, right? So if it's back in quadrant 1, everything is positive. So the answer has to be D. But that is definitely a math by mistake. If you look, I kind of showed it, but maybe caught on. If I make that translate here, you can see that one of them is actually in the negatives here. So the correct answer is no longer D. If I look here, it doesn't intersect the x-axis. It goes a little bit over the y-axis. It's not a reflection. Again, going back to area and perimeter, the area is equal. It hasn't changed because, again, any type of translate, reflect, or rotate keeps it congruent. So the correct answer here is C. All right. Let's take a look at this question here. So now, if I look here, all right. So we're going from EFGH to this EFGH. Okay. So first thing wants to know is, well, what's happening to go from there to there? Well, it looks like we're translating, right? It looks like it's going 2 right and 2 down. So I would say 2 to the right and 2 down. So that would go here, 2 right, 2 down, translate. What's my math by mistake there? Yeah, it's not 2 right, 2 down, because notice how I went from F to E. It's more than that. If I do it correctly this time, I'm going to go 1, 2, 3, 4 right, 1, 2 down. So the correct answer here is still translate. We're still sliding, but it's 4 right, 2 down, translate. And if you like the vector notation, you would go 4, comma, negative 2. Is the parallelogram congruent? let's not make a mistake here. We just talked about that. So, of course, they're congruent to each other. They're just slid. They're exactly the same. So the answer here is yes. Sliding keeps same size, shape, exact same. All right, let's see if there's a little bit of interesting stuff on the back here. Let's take a look. So now it says going again with congruent figures here. So it's going to take that one, the prime one, and reflect it over the x-axis. Um, yeah, will it be congruent? I think if you move something twice, because it's been already translated then reflected, it's not congruent. Unfortunately, that's a math by mistake. If you look back to the original figure here, if I reflect it over the x-axis here, and I think we're going this one, reflected over the x, it's just going to be flipped over. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, 4 to my line. 1, 2, 3, 4. 1, 2, 3, 4, and then this one's here. So again, just sketching it out, the reflection doesn't change that they are indeed congruent. So the answer, math by mistake, is yes, congruent. Great. So hopefully looking at those, you know that if anything is reflected, translated, rotated, it stays congruent. Okay, let's take a look at this example here. A good old reflection again. It says here, point W not shown on the line segment here will be reflected over the y-axis. What will be the new coordinates? All right, well, let's just make a point W here. So it doesn't matter where it is. And we'll reflect it over the y-axis. So we'll go 1, 2, 3, 4. 1, 2, 3, 4. W prime. Okay, it looks like my x is negative and my y is negative. All right, both in the negatives. And if I look, that is not any of the choices. Well, let's see too. Wait, hold on. I might have made a mistake here. What happened to my x and y? Did it change? Let's see. My x was -4. So my x was -4, and it stayed -4. So x did not change. But my y went from +4 to -4. Aha. So it must be C. But wait a second. Did anyone catch my math by mistake? I went over the wrong axis. It says reflect over the y. I went over the x. So the correct way to do that here would be here. And then this is my imaginary W. 1, 1, 2, 3, 4. 1, 2, 3, 4. W prime. And you remember when we did this, if we reflect over the y, let's see here, the y does not change. It's still going to be 4. So it's going to be still 4. But now x does change, right? X does change because it went from being -4, 4 to 4, 4. So the correct answer is actually D. Great. All right, let's look at some rotations. Trying to see how many more. I think we'll stop this video after all my transformations, and I think that would leave us with 3 more questions left. So let's take a look here. All right, rotations. Now remember, rotations is still going to keep everything congruent. So it says 90 clockwise. So, that's easy. So 90 clockwise, it's in quadrant 1. We'll go clockwise here. And it's probably going to be like standing up a little bit like this, just kind of sketching it like that. So definitely the answer has to be this one. All right. No, math by mistake. That's hopefully an easy mistake for you to catch. That is not clockwise. Clockwise would definitely be more this way here. So now I'm going to end up in this quadrant, but you can kind of tell if I rotate it, it's going to be facing like here, and then here, and then like here. So I would go with, and you can see it gives you the letters. So B, B prime, C is going to be way down here. So I would go with this choice here. Math by mistake. All right, next question. Almost done with this first video. Let's keep going here. In this example, okay, let's see what we're doing here. Sorry, here. Okay, so in this example, it says 180 degrees here. So let's see. If we do 180, we know we're going to go into, this would be 90 here. So I would say, let's not make a mistake here. I think it's pretty clear to tell that when you go here, here, you're going to be x is positive and y will be negative. So I'll say x is positive, y will be negative. So that's the answer here. All right, next question here. Let's see. Haley transformation of QRST will form, where they're both negative. Okay, so if they're both negative, we were here, now we're here, and I guess we just have to reflect it over the y-axis, and now we're both negative, right? So I guess the answer has to be A. That's a math by mistake. Okay, I didn't read the directions clear enough. So it's actually taking the original QRST and making it a double prime. So Haley's transformation of quadrilateral QRST will form the double prime. So if I want to go here and make them both negative, I actually have to do a reflection over the x-axis. So the correct answer here is reflection over the x-axis. There, that is the correct answer. All right. Yeah, we are just about done with transformations, and we'll head into solving equations. All right, let's do it. Last one here. So reflection, rectangle M and PQ is shown on the coordinate plane. So it's here. Okay, so too easy. Let's take a look here. So if I'm doing this one, all right, that translate will keep it congruent. Rotations will keep it congruent. A reflection will keep it congruent. And then, a dilation. A dilation, that's going to make it bigger. That's going to be similar but not congruent. Did anyone see my mistake? Because I made a math by mistake. Yeah, I didn't read the directions again quick enough. And there was a second thing happening here. It says, then it's a scale factor of 2. Bum, bum, bum. So now that means here, the correct answer was congruent, congruent, similar but not congruent, similar but not congruent. Because again, as soon as you scale factor something and you dilate it with something bigger or less than 1, you're going to make it bigger or smaller. So now you're dealing with similar figures. All right, I believe, let me just double check. That's it for transformations. Just speak, and just because we're here, before you leave, before we end, this one's a scale factor question. So it says, it looks like a Pythagorean theorem, but it's not. Which of the following pairs could be similar? So if you have to think about what would multiply, and I can tell just by looking at it, if I multiply this by 3 and this by 3, I get 15 by 24. And that is choice D here, 15 by 24. Okay, so now I think we're done. Let me just double check my papers here. All right, so now We're going to go into linear relationships for the next episode of MCAS by mistake.